Welcome back, everyone. Today I'm going to be solving and explaining how to solve a hard LeetCode problem. Let me share the link. And let's read it. Find longest awesome substring. It's a hard, like I said. You are given a string S. An awesome substring is a non-empty substring of S such that we can make any number of swaps in order to make it a palindrome. So this is not very clear. It turns out that it is explained here, for example, in example 1, where you have this substring, and yes, it's clear that if you swap the 2 with the 1, then it becomes a palindrome. So if there's a way to reorder the characters such that you get a palindrome, then it is awesome. And you have to return the length of the maximum. The maximum length, the length of the maximum length. This is this statement is a little odd, a little wrong. Awesome substring of S, but I guess it's clear what needs to be done, and there are examples to clarify, so it's okay. And the length is at most 10 to the 5th. And this is interesting because it consists only of digits. I don't know why. It could have been letters, and it would, I guess it would be the same. But that's something suspicious, that when you need to suspect that when you're trying to solve a problem, you need to pay attention to those kinds of details, because this could have been letters, like 26, an alphabet of 26, but it's an alphabet of 10, size 10. Hey, smart coder, how are you? And it could also have been just a list of numbers with some arbitrary range. So we need to keep that, to pay attention to that. Okay, so let's work out an example so that we get a feel for the problem. So 3242415. 3242415 is what I said, and the answer in this case is this substring. And one thing to notice is that, well, once you define the substring, the order doesn't matter because you can change the order. So let's say that we transform this substring into a kind of a multiset or a counter. So, or we can just have an array with the counts of each digit. So let's say that, well, we have 0 zeros, this is 0, 1, we have 1 1, we have 2 2s, we have, oh, yeah, all right. We have 0 3s, and we have 2 4s, and No, this is not in our substring. All right, so this is effectively a palindrome. We can reorder it to form a palindrome, and the condition, which is it's not hard to realize, that is related to the parity, because palindromes, there are pairings. So for example, here if you have 2, 4, 1, and 4 and 2, so this number has to be paired with this one, and this one with this one, and this is the odd one out. So it is related to parity, and all the numbers here have to be even, with the exception of 1, which can be even or odd. I mean, you can have one odd if the length of the palindrome is odd. So given that only the parity matters, instead of having the counts, we could have the parity of the counts. So this would turn out to be 0, 1, so 2 has parity 0. Is a reminder. So this boils down to just having a 1 in position 1. It's the only one odd. And so for a substring to be a potential palindrome, this counter has to have only 1, 1 and all zeros, or all zeros. Those are the only options. So that is interesting already. So how do we find? We cannot go over, like usual, since the length is 10 to the 5, we cannot go over all the substrings. We need to be clever. So one usual trick is to fix one of the sides of the, so let's call it the right side of the subarray, and then we want to find the left side that makes the longest substring. So let's for a moment forget about which one is the best. Let's say that we have some left pointer and some right pointer, and we want to know quickly, we want to calculate this quickly. Okay, how can we do that? One thing to notice is that, well, here I wrote it, I only have from 0 to 5, but we could need from 0 to 9 inclusive, so 10 elements. But since we're only saving the parity, every element can be 0 or 1. So that's where bitmasks are a convenient way to represent this information. So we could turn this, we can transform this into just a number which with a binary representation. With this binary, well, actually it would be the other way around, since this is there's 0 zeros, there's 1 1 0, so on and so forth. So that's interesting again, because we can represent these kinds of counters. I think what did I wrote? what did I write in the in the title? Bitmask. Prefix sums as well. Yeah, I gave it away a little bit, but let's say that we want to compute this number, this bitmask, for given a left pointer and a right pointer. And so whenever you need, this is what's called a range query. We want to compute something. You should stop giving away the solutions in the titles. Yeah, I mean, it's a clue. It's not given away completely. I'm sharing the problem in the Discord server so that you can think about the problem beforehand. And even when I upload the video, well, I guess you read the title and it gives you a hint. I just learned 2 pointers a few days back and prefix sums just yesterday. This is going to be interesting. Great. Yes, exactly. So yeah, this is like a twist on these techniques. You might not recognize that these techniques apply initially. So, okay. So we want to compute, we have a range query. When you have a range query, a usual technique is to use prefix sums. And so we could compute this number for the prefix from the beginning to right, and then from the beginning to the element before left. And if we cancel out the common prefix between those two, then we're gonna have the counts for the intervals for the range. And how do we cancel them out? Well, one trick to do that is to do an XOR. Which it's the same as doing, we want to, these are like sums in modular arithmetic, modulo 2, because of what we said that we only care about the parity. So in some sense, we are adding and subtracting, in that case, modulo 2. And if you think about it, when you do an XOR, the XOR, it's the same as that. For example, if you have X and Y, whenever you think about bitwise operations, you should consider doing a table for all the combinations. I guess you maybe saw this in school. So there are 4 combinations. Hey, Tallway, thanks for the follow. And so the XOR is 1 when you have a 0 and a 1, or vice versa. And in this case, it's 0. So this is the same as adding mod 2. When you have, so these are trivial. There's nothing. So if you add 0 and 1, you get 1. 1 and 0 is 1. 0 and 0 is 0. And here, 1 and 1 is 2, but the parity is 0. And subtracting is the same as adding. So that's why if you have the prefix for right minus, the XOR, which is written as the pointy hat in the prefix of left -1, then you're gonna have the mask, or whatever you want to call it, the counts from left to right. Pointy hat, haven't heard that word since high school. Yeah, carrot is called. I don't know. So, okay, so now we figured out how we can quickly find the count for a given substring, but we haven't finished yet because we need to find. So how do we know? So let's say now that we only have right. We cannot go over both all the subarrays. We only have right. So, and we said that we wanted to find a subarray that has a number which has only, that is represented by the number, the counts are represented by a number that only has either one bit on or it's all 0. But that is going to be the result of this, right? This is kind of a two-sum kind of situation where we have an equation, right? We have an equation and we have one of the variables we already know, which is the prefix of right, and we want to find the prefix of left, so that the counts are one of, so there are only 11 possibilities, right, for the counts that we care about, that are awesome, as they say in the problem. So we can try them all. Okay, so for example, we have this, and we know what the prefix is. And one way to solve this equation, so if you have x, y XOR c, one useful property of XOR is that when you XOR a number by itself, it's 0, and when you XOR 0 with any number, you get that number. So here, if we XOR y on both sides, we're gonna get, well, this was another letter, okay? So anyways, all I'm saying is that to find the left, we need to XOR the counts with prefix right, that we know what it is. And the counts, we know that there are 11 possibilities, so we can also know what they are. And when you, no, I mean, that's okay. So that it's going to give us all the prefix lefts that form a palindrome. But there could be more than one, right? There could be more than one prefix that has the parities that we're looking for. And that's when the maximum length comes in, because if there's more than one, we want to we want the leftmost, because that's going to give us the longest. Hello, Amuga. We want the leftmost because that is going to give us the longest substring. Okay, so I hope this was clear. If there's something that is not clear enough, I can try to explain it differently, but let me know. So let's start coding. So how do we... So we want to... When we solve this equation, we are going to get the prefixes that we care about. So we need a way to access for this mask. We need to access the index of the prefix. And XOR what are we doing? We're solving a problem, a LeetCode problem. I shared the link here. Let me pin it. Anyways, if you're interested, you can find if you missed the beginning, you can watch the bod when I finished. I'm gonna upload it to YouTube as well. Anyway, so yeah, we need a mapping or a dictionary from the mask to the index where that prefix occurred. And as we said, we want the leftmost. We want to keep the leftmost to maximize the length of the substring. So what do we need? And again, we are going to keep track of a yeah, let's call this prefix, which initially it's going to be 0, which means that there's 0 of each, all have parity 0. Then we want the index for a given mask, and we have this special case of index -1. We want to imagine whenever you do prefix sums, it's usually useful to have like a special value for a position to the left of the first, so that the calculations work out without having special cases. And then we're going to keep track of the maximum in the res variable. And so we want to, so let's call this right, and we are gonna have the let's call it x, the digit, and we're gonna, since they give us the digits as a string, but it's easier to work with integers, so let's map it. And so first we're going to include this element into the prefix. The prefix has the count from the beginning up to the right, the element at right, inclusive. So to make it inclusive, we need to XOR the at this position. That's going to toggle the parity of the digit x. So now we are including the right element as in our prefix. And we are going to compute we want to compute the left. So we said that there were 11 possibilities. So let's call them candidates. There are 11 possibilities for then the counts that are awesome. Okay, so let's go over all of them. So let's call this Y. So here there are 10 masks that have the Y digit, binary digit on. And we want to XOR them with the current prefix. And that's going to give us our candidate left. And we said that there were 11 because it could be the case where none of the bits are on, in which case the candidate is pref itself. And now for each of the potential lefts in the candidates, we want to know if left is in the index dictionary, because if it's not, it means that we never saw that combination, that prefix, so we cannot use it. Notice that there's always going to be at least one candidate left, because there's always an awesome string if you have only one character. That's always a palindrome. So there must be, for every right, there must be at least one candidate that is awesome. It could be short, but it could be only length 1, but there's gonna be one. So that means that we don't have to handle special case where there is none. And here we want the corresponding index, and we want the minimum. And that's gonna give us the best left for this right. So now we just get the minimum. And the minimum is going to be right minus left. Yeah, that's correct. And finally, we need to update the index dictionary, which, like we said, we want to keep the leftmost. So if we already added an index for a mask, for a prefix, then we don't want to update it, but because that's going to change the index to a bigger index. That's not what we want. So if the prefix is not in index, only then we set the right index to it. And that should be it. Passes the examples. And is there any special case? What about if it's only one digit? Does it matter? Let's see. It's cool that while it passes, it's pretty useful to get the answers for any case that you can input, that you can add. That's very convenient. In contests, you usually don't have that luxury. But in practice, you did not understand what exactly the whole. Maybe you started the stream late. Everything. Yeah, like I said, this is a hard problem. I'm assuming some previous knowledge, but not much. I tried to explain as much as I could, but maybe the fact that you didn't see the beginning of the stream didn't help. So that's why I recommend you to watch the video afterwards if you're interested. Again, let's try to submit it, and it passes. Cool, accepted. All right. I'll rewatch after. Okay, thank you. Yeah, let me know if you have if you have specific questions. I can try to explain something again. Try a different way to explain it. But yeah, I thought it was neat. Maybe we can do a recap over the idea of trying 11 candidates with the XOR against the pref itself. GG. Yes. I wanted to do like a recap, a high-level recap, but we can dive again into the justification for. So what I said was that for a substring to be awesome, or in other words, to be feasible to reorder into a palindrome, to be reorderable into a palindrome, when you count the occurrences of the digits in that subarray, then the parities must be all zeros except possibly 1. So that means that you need to have there are 11 options. You either have 10 zeros, or you have a 1 and 9 zeros, and the 1 could be in any of the 10 positions. So that's why there are 11 ways in which you get a palindrome. And then I explain how you could quickly figure out the discounts for a range that is determined by a right pointer and a left pointer. How you can do that quickly without going over the range. And what I explain is that if you have the prefix, the counts for the prefixes, then you can do an XOR, which is equivalent to the difference in the prefix sums. The prefix is equivalent to a difference in mod 2. What if you have different numbers instead of 1 and zeros? How can they be a palindrome? The 1s and zeros represent the parities. Here I went over all the transformation. You initially have this string of digits, which is what you get as an input. And here I'm selecting this substring, which is the answer for the example 1 in the problem. And what I said is, well, what if I represented this as the counts for each of the numbers here? So here I have 0 zeros, 1 1, 2 2s, 0 3s, 2 4s. This corresponds directly to this. And then what I said is that in order to see if it's a palindrome, I only care about the parities. So I can transform all the numbers into 0 and 1, the remainder when divided by 2. And that's how I arrive at these representations with bit masks, where I only have a 0 or a 2, or a 0 or a 1 for each position between 0 and 9 inclusive. So going back to this, so this is the idea of prefix sums to compute range sums, but you translate the difference into an XOR operation, a bitwise XOR. And then you have a situation similar to two-sum, where you have an equation. So again, we know, like I said, we know that there are 11 possible counts. So we go over each of them. Here's an example where you have 1 1 in position. So this is 0 1 2 3. So you have only 1 3. No, you have only an odd number of 3s and an even number of all the others. That's one type of palindrome. So that means that this is fixed and this is fixed because we are going over all the right pointers, and this is our unknown, the prefix left. So as usual in two-sum type situations, we just solve the equation, and it turns out that prefix left has to be this XOR this, the counts for the prefix up to right. That's how we know that prefix left must be this value. And then we talked about what happens if there's more than one, and we said, well, we want the first one that we saw, which is the leftmost, which is the one that is going to maximize the length of the substring. So Lucia, do you think that's clearer? Cool idea to keep the first left for each mask. Yes, here's where this conditional prevents that, makes us save only the first that we see of each mask. So here, when we get the index, we're guaranteed that this is the leftmost for that left. Yeah, I guess it is a little... Yeah, it's wrong that I'm using left here, because this is a mask actually. So this should be called like pref left. Right? Because I should not confuse the mask with the index. I mean, it works. It worked, of course, but I think this is clearer. So yeah, let me share the code. So the speed is okay, like 53%. I'm not gonna worry about that. So let me share my solution. And yeah, that's all I have. But if you have more questions, I can keep going. I don't mind. I want to make this clear. I think it's cool. I think it's a interesting technique. And this idea of using bitmasks to represent this kind of counts, this to represent sets in a sense. You take requests. You mean for another problem? I wasn't planning on doing other problems now. I might do another stream later, which is going to be more free. So I want to save this video then for I want to have a video to explain this problem in particular. Yeah, the answer is no. Yeah, but I'm explaining why. I want to keep the videos focused on one problem or one contest so that I can then upload them to YouTube and someone can watch it for that purpose. But I might do other streams that are more free that I'm not gonna upload to YouTube. Cool. Yeah. I think it's different kind of content, but yeah, I'm focusing on this kind of content lately. Okay, so if there's no other questions, I think it's all clear now. So that's all I have. Let me know if you have any feedback. You can add comments. Nice solution, thank you. If you have any feedback, let me know in the YouTube comments or in the Smart Coders Discord server or wherever you can find me. Okay, so thanks a lot for the support and see you in the next one.